Okay, here we go. Switch over so you can see it better. All right, so there's the basic problem. And as defined, we were looking for BC, QG, and FG. Those are our three. So again, I'm kind of going to imagine some kind of cut through the structure. And as we talked about previously, we're probably going to work the left side. That seems reasonable. So when I'm doing that, working the left side, I'm going to worry about AY and AX. I'm not actually going to worry. I'm just going to need to find those values. And we would consider a Y component at E. We may not have to do that. So looking ahead that we're going to work the left-hand side, we want to find just the reactions at A. What are we going to do first? Define AY. We're probably going to sum the moments created about E. So let's do that. So I'm using right-hand rule, and we're summing the moments about E. So about E, you can see EY and this 500-pound force pass through E, no moment. But I'll have a moment created by the 800 and the 500-pound force, and they're both going to be what? Positive or negative? About E, with right-hand rule. Positive. So I'll start with the first one, 800 kips. Its moment arm is this horizontal distance, 10 feet. Plus 500. I said kips, but it's actually pounds. Sorry about that. And then the distance between the line of action here passing through E and B is 20. So I've accounted for those forces, and all I have left is AY, which is creating negative moment, and it has the same moment arm as the 500-pound force, 20. So I should be able to find AY. I think it's 900. What do you think? Anybody calculate that?
Yeah.
I heard one yeah. Can I get two yes? Excellent. I always like two yes. Yeah. I guess being a Beatles fan, I have like three yes. Miss Holland, yes.
Can you show me again why AY has 20 feet?
Well, remember, we're summing moments about E, so I'm just going to imagine a line of action passing through E, right? And you can see all these other forces, being parallel, and it's the distance between them. And the distance should be 10 plus 10. Okay, so now we need to draw our free body diagram. And I'm going to work on the left side. So here's where they're kind of being cut. So this would now be the force in BC. This would be the force in CG. And this would be the force in FG. I've got an applied 500-pound force there. This is 10 feet. And I found my reaction was 900 pounds and acting up. I think that's everything on the free body diagram. Does that look okay? Now, if you look at this setup, it's very similar to the last two problems we've done. So the strategy should be the same. Let's start with moment, using our moment equation again. Where would be a good place to sum moments? Again, look at the subscripts of your forces. That should give you a big hint. I forgot to label this as G, B, and A. And I will add a little visualization. I'll show you that if you do extend the line of action of those forces, you should end up in C. So hopefully that'll make it easier for you to choose. So what's your choice? I'm sorry, Miss Felix, what did you say? C? C sounds like a great place. Let's start there. So right-hand rule for our sign convention. We'll sum the moments about C and make sure they're in equilibrium. Okay, so about C, what creates moment? Let's go to the unknown force. We see that CG passes through C and BC passes through C, so they'll create no moment. So the only force left is FG. Now, in its orientation here, is it going to create positive or negative moment about C? Positive. So I'll say the unknown force in FG. And what's the moment arm, which will be the distance from C to this? What's this distance right here? It's 5. So I have a moment arm of 5 feet. Now with all these accounted for, I just have these two forces. Let's do the 500-pound force first. Is it going to create positive or negative moment about C? Positive. So I'll have 500 pounds. And its moment arm is, distance from C to B, 10. And then 900 creates positive or negative moment about C. Negative. And also 10. I left my unit off there. Sorry, I'll try to squeeze it in here. Now another way to do it, since these both have on the same line of action, is just take the resultant force, which would be 400 acting up, and you'll get the same result. But from this, I should be able to solve for the force in FG. And I'm thinking it's going to be 700? 800? Yeah. So it should be 1,000 minus 1,800, right? Negative 800, correct. No. 800. Sorry. You guys are way better than me. 800. So that says that FG is in tension. Does it make sense that this is in tension? Well, look back at the original diagram. With these loads applied, how is point E going to move? Left or right? It'll move to the right. So as it moves to the right, this whole bottom chord is going to stretch. So that's why FG should go into tension. And it does. Okay, so how do we find another one of these forces by summing moments? We already used up C. Is there another point where two of the forces pass through? G. So let's sum moments about G. Everybody see that? I think that one's easier to see because both the... Plus remember, FG, CG, GGG. So going about G, I have BC, and again these two forces that I had to deal with before. So let's go about G. What's the moment of BC about G? Positive or negative? Negative. So it'll be the force in BC. And what's the moment arm? The distance between G? 5. And now let's do the 500-pound force. 500-pound force about G creates positive or negative moment? Positive. And its moment arm is the distance from G to that line of action. Should be half the distance, or 5. And then I have the 900-pound force creating negative moment, also 5 feet. That looks pretty similar. So what is the force in BC? It looks like it's going to be negative, right? And what is it? 400? 400 it is. So it should be negative 400. You can see they all have the same moment arm, so if you cancel it out, move BC to the other side of the equation, you just have 500 minus 900 minus 400.
What about carrying the sign? Is that
carrying the sign?
one negative F of BC times 5?
Well, what I did is I first divided everything through by 5.
Okay.
Then I just moved BC to the other side of the equation.
Okay.
that made it positive. And I just had 500 minus 900 gives me negative 900, negative 400. Okay, so now we're just left with the force in CG. And conveniently for us, it's the only force with a y component. So I would now sum forces in the y direction. Now before we do that, let's go back and look at this particular force. What's the rise over run there? It looks like it goes up 10 and over 10. So that's a 1-to-1, 45 degrees. But remember, I always like to do the hypotenuse. So the hypotenuse of that triangle will be square root of 2. So now I know that the vertical component would be up, and it would be 1 over the square root of 2. So I would have 1 over the square root of 2 times the force in CG. That's acting up. And then I have minus 500 plus 900. Did I leave anything off? I think I've accounted for everything. So I should be able to find the force in CG. It looks like it's going to be negative. Right? It looks like it's going to be 400 times the square root of 2. What's 400 times the square root of 2?
565.
555?
665.
5. That's close enough. Oops, sorry. So there we go. So that would be in compression. So any questions about that? Yes, Ms. Wiseman.
How would we know not to use the 800 pounds at sea when you're doing seating?
When you're summing moments about C?
No. When you do the FY.
Well, see, we cut the structure here. So when we look at the left side, 800's not there. If I'd have cut it like that, yeah. But I would have gotten 3 different forces, right? So have to be careful. Okay, any other questions? No?
Is BG a zero force moment?
BG? No. We solved for BG, didn't we? Oh, you said BG, I'm sorry. BG would not be necessarily zero force. If you look at G, you can see it's 1, 2, 3, 4 members connecting. If you look at the other side, it's 3. So it doesn't follow into any of the classic cases that we talked about, the case 1 and the case 2. Okay, so I'll stop this here now.